Okay, this device is for most renewable energies that are low voltage output, such as photovoltaic, such as fuel cells. The output is extremely low. Each cell is like 0.7 volt, and even if we stack it up 10, 20, 30, the voltage is still very low compared to what normally we use in the utility environment, that's 120 volt, 240 volt, and you cannot use that low voltage DC output directly from the renewable energies for the home appliances, for the utilities. So what we do is we convert this low voltage DC, which is also variable. It changes whenever there's light change, when there is load change, the voltage changes accordingly. And our V6 converter is to convert that low voltage variable DC to high voltage fixed DC. And the high voltage typically is required to be 200 volt for 120 volt AC and 400 volt for 240 volt AC. So with that kind of conversion, we basically boost up quite a lot, and it's very difficult to make it efficient. And so we make it with multiple phases. We call V6 with the 6 phase, so that the loading of each phase is divided. And then we also make a connection with a special type of configuration so that we can switch the devices at the very, very low loss condition, so we can get very high efficiency. So it's a high efficiency power conversion from low voltage DC to high voltage DC for the next stage, DC to AC power conversion. Some companies are doing is to convert the low voltage DC to low voltage AC, and then bring a conventional 60 Hertz utility type transformer, so make it available for home appliances. Okay, so this type efficiency is not bad at all. The problem is the size of the transformer and the weight. It's huge. People may not realize 60 Hertz transformer is not that cheap. They're copper and weight, very heavy. In the end, your price of the electronics comes down when the quantity is high, but it cannot come down the price for the copper and iron with quantity. The price is fixed. And so we effectively we increase the fuel cell capacity by 20% using our DC-DC converter intelligence, that control.
Because the ripple doesn't get back to the fuel.
No, it's totally killed. We can make it cheaper because we use multiple phases interleave, and we cut down the ripple, we cut down indirectly, we cut down the passive components, the copper and iron, the size of copper and iron, or they're cut down dramatically. Typically, compared to traditional design, traditional DC-DC converter design, like this kind of power level and this kind of configuration we call the full bridge DC-DC converter that you can find from the textbook. And we compare the size is 12 times smaller. So if we compare to that state-of-the-art textbook kind of design, we cut the passive component by 12 times.
And increased efficiency.
Yeah, and increase the efficiency.
That's a lot.
You won't see that in any other technologies.